this problem is going to be finding the parametric and symmetric equation of the line passing through the point 2, 1, 0 and perpendicular to the lines I plus j and j plus k. So we know that our equation of a line is the vector r is equal to the vector r naught plus t times the vector v. And they give us the position vector r naught as that point, which is 2, 1, 0. So our parallel vector is going to be equal to the cross product of I plus j and j plus k, which are the vectors they give us because they tell us that both of these are perpendicular to the line we're trying to find. So we know that these are parallel to each other, and when you take the cross product of two parallel lines, you find the line perpendicular to both of those, and that's what we're trying to find because the line perpendicular to these vectors will give us the parallel line for the equation of this line, which is going to be our vector v. So we're going to take the cross product, and we know because these are unit vectors that they're going to be 1, 1, 0 and 0, 1, 1. So you take the cross product of that and you end up getting the vector 1, negative 1, 1. And then we can plug all of this information into our equation. We already have r naught, and then we have plus t times the vector v, which we just found, and then we can distribute t to this vector, so you get t, negative t, t, and then you can add these in, and you'll get the vector 2 plus t, 1 minus t, and t as our vector r. So that's already in our parametric form. We just write it individually, x equals 2 plus t, y equals 1 minus t, and z equals t. And then symmetric form is when you set it equal to t, so doing some simple algebra, we'll get x minus 2 over 1 equals y minus 1 over negative 1 equals z over 1, which we can simplify to x minus 2, which is equal to 1 minus y, which is equal to z.